Hi guys, let's get going. You have a test tomorrow. The good thing about this test is that there is a lot of review. There was only one new concept for this week, so I think that's going to help you guys out a lot. And I believe all your teachers are going to, if you do better on this one, replace your exam 9 with the exam 10 grade. So there's a lot writing on this for you guys. Let's get started. Let me grab a couple colored markers around here and let's go. Okay. So first things first, factor versus solve. Factor versus solve. All right. When do we factor? When do we solve? The easiest thing to remember is that you're only going to solve when there is an actual equal sign in there. So this guy right here, it's always in the directions too. Just factor. Sometimes it'll say simplify. Simplify is another word for we're not solving. Okay. So to do this problem, this is a review problem. You're going to do the X method. You're going to multiply the A term times the C term, which in this case is 3 times -5. That gets you -15. You put your B term on the bottom. That's -2. And then you look for your factors of -15 that gets you -2. So in this case, we're going to do 5 and 3. All right, but we need a negative somewhere, and we need the 2 to be negative also. So we're going to make this one -5 times 3 is -15. -5 plus 3 is -2. So that one's all good. Remember, you got to drop your A term. So we need to drop the term, the number that's in front of the A here, and that's 3 and 3. This side, if you can reduce, you need to reduce. So this is going to reduce to 1. Okay? This guy right here is already reduced, so my factors are 3x minus 5. Remember, whatever's on the bottom comes in front of the x. And this guy right here is just, this is like 1 over 1. So if you want to write it like that, that's fine. You can do that. But there's your answer, 3x minus 5, 1x plus 1. If you're not sure if you got the right answer, FOIL it out. Put it in the Punnett square. Use the vertical method. Whatever you need to do to make it easier for yourself so that you can check your work and see if you got it right. Okay, number 2 is solve. So the first thing you need to look at when you solve is you need to make it equal to 0. And if it's not equal to 0, you need to get it there. So this one's equal to 9. In order to make it equal 0, I know I need to subtract 9 to both sides. And that gets me 2n squared plus 3n minus 9 equals 0. Okay, let's forget about the 0 right now. Let's just go about our factoring business like we know how. A times C, -18. B on the bottom, +3. And come up with our factors. So for this one, I like 6 and 3. I need this one to be positive, but I need up here to be negative. So I'm going to make this 3 negative right here because 6 times -3 is -18. 6 minus 3 is +3. And then don't forget, you need to drop your A term. And in this case, your A term is 2. All right. Simplify if you can. This guy right here can be simplified. That's 3. Okay. I'm going to zoom in a little bit for you guys here so you guys can see it a little better. Write your factors. So for this one, I have n plus 3, 2n minus 3. And here's where we need to make sure we remember our 0. Once it's equal to 0, you need to use what's called the zero product property. And that's a fancy term for just set it all equal to 0. So n plus 3 equals 0. 2n minus 3 equals 0, and then solve. Regular equation. Subtract 3, n equals -3. Add 3 here, 2n equals 3. Divide by 2, n equals 3/2. So my answer for this, I'm going to put it up here. You'll see the answers when you solve. They're going to be in these braces. It's going to be -3 and +3/2. Okay, that's your answer. When you solve, remember an equal sign. We need to get an x equals this and an x equals that. Factor or simplifying, you leave your answer in terms of factors. Okay, let's go here. Factor completely. So this was kind of a new concept. We didn't ask you to do this last week. But before you start this, you're going to want to take out the greatest common factor. So in this case, the greatest common factor is 3. When I take that out, I have 5n squared minus 9n minus 2. Okay, do not put an equal sign there. There was not one in the original equation. Don't get fancy trying to make stuff up. Just leave it as it is. Once you're here, factor that. Don't forget about this 3. You're going to leave it there until the very end. So we're going to get negative 10 and negative 9. And I'm looking for factors of negative 10, which are pretty easy because it's 1 and 10 and 2 and 5. So 1 and 10. I need negative 9, so my 10 has to be negative. I need to drop my a term. Always remember to drop the a term, and in this case, it's 5. Reduce, if possible, negative 2. So my factors for this are 5n plus 1 and minus 2. This is where you need to be careful. This is not your final answer. You factored this, but don't forget about this guy out here that you factored out in the beginning. So you just need to make sure in your final answer that you include him at the end. So your answer will look like this. It'll be 3 times 5n plus 1 and minus 2. So factor completely means pull out the greatest common factor and then do the x, get your factors, and make sure you don't forget about this guy hanging up out here. Okay, let's solve. What's great about this is already factored. This means that I have 2 of these, x minus 3 equals 0. Okay, it's already factored. So I just use the zero product property. X minus 3 equals 0, x minus 3 equals 0, and solve. Add 3, x equals 3, add 3, x equals 3. And it is possible to get one solution. All right. It is possible to get one solution. And we're going to go over this next week when we get into parabolas. You guys will learn that these are actually parabolas. And when we do these, you'll see what one solution actually means. But that guy's okay here. This one right here. Solving. Okay, again, solving. X equals something else. This guy right here is already factored. Okay, so zero product property. 3x equals 0, x minus 2 equals 0. All right, we divide both sides by 3. X equals 0. Don't tell me that's no solution. That's a 0. 0 is a solution. If you guys were to graph this, you can find 0 on a graph. Add 2 here. X equals 2. So my answers for this are 0 and 2. All right. Factor, difference of squares. Recognize the difference of squares. 25, 49. You have the subtraction sign. Okay, that's what a difference of 2 squares is. So these guys right here are super easy. You just want to factor, meaning your answers are going to be left in factors. And I see that they're perfect squares. So this guy right here is 5 and 5. 5 times 5 is 25. X squared is going to be x and x. And 49, I know, is 7 and 7. And the cool thing about a difference of 2 squares is that you just know that one is plus, one is minus. Again, if you're not sure, FOIL it out and check it. You guys will come back with this answer. If you do something wrong here, like if you were to write 5x minus 7, 5x minus 7, and FOILed it out, you would not get that. So you have an opportunity to check your work all the time with these. Okay? Solving down here, again, super easy. Already factored. X minus 5 equals 0. 3x minus 2 equals 0. Zero product property. Add 5. X equals 5. Solve your equation like you know how to solve your equation. Sorry, that equals. Divide both sides by 3. X equals 2/3. Solving here, your answer is 2/3 and 5. Okay, last one. on this page. Factor. 9 and -7. Factors of 9 that are going to get me a 7. Well, my only factors of 9 are 1 and 9, 3 and 3. And nothing works. If your factors don't work, this is called prime. Okay, when you have no factors, it's called prime. All right, so that's simplifying and factoring. If you have questions, put it in the chat. I'll come back to it when I'm done with the whole thing. Again, the new stuff on your test, honestly, was just setting them equal to 0. When it's equal to 0, you solve it. That's the only new concept on your test. Everything else is review. So let's get to the review part. This right here is, I think, about 50% of your grade. Factor solve, which one is it? Okay, let's get to the review. Now, this should look pretty familiar to you guys. This is kind of I stole it from our previous tests to help you guys out, to show you what was going to be on here. And I think what I want to kind of get to you is that, what do solutions mean? We keep talking about solutions, and solutions mean different things for different types of equations. So this guy right here, to the nearest whole number, where do the lines intersect? Okay, so they intersect right here at 3, 8. Okay, but that doesn't mean anything, all right? What does that solution mean? That's the solution. What does that mean here? Okay, and in the context of this problem, yes, it's the point where the lines intersect. For this type of problem, it means that the same amount are the miles and the cost. So at 3 miles and $8, both the yellow cab and the blue cab are the same cost. So it's always important to understand what a solution is. And in a system, this is a system of equations, your solution is where the lines intersect. Okay? For this one down here, what are the solutions? Okay? Given the graph, circle the ordered pairs that are solutions. Solutions in an inequality are the ones that are in the shaded area. So when you get an inequality, it's the ones that are going to be in the shaded area. So if you're given a graph like this, you're looking for the ones that lie in the shaded area. So this first one right here is 0, 0. Well, 0, 0 is right here. Is that in the shaded area? Yes, it is. That's good. Okay. -4, -4 is somewhere down here. Is that in the shaded area? Yes, it is. Is 1, 3 in the shaded area? No. Pi -3. I love this one. Pi, we're just going to use the approximation for pi, which is 3.14. So we have -3.14, which is like somewhere around here. It doesn't matter. But we're going down -3, which is at least somewhere down here. Yeah, that's well within it. How about 0, -5? Clearly not. -22. So -20 is way over this way. Somewhere over here. Here's -20. But we know 2 is up here. So here's -20, 2. That's definitely not in the shaded area. When you're given problems like this, you're looking for the shaded area. So let's say you're not given the graph. If you're given 2 inequalities, like y is greater than 2x plus 1, y is less than 3x minus 2. And they want to know what points are solutions, you literally plug them in for x and y. Okay, you plug them in each time. So if I were going to do this, I would plug in, here's my, let me do one that has a different one. Here's my x, here's my y. Okay, and I'm going to plug them in. And remember, it has to work for both. All right, has to work for both. So if you're given a system of inequalities and you're not given the graph, you literally are just plugging in to see if it's true. So let's take this one. Let's take 1 and 3. If I'm plugging it in here, I'm going to get 3 is greater than 2 times 1 plus 1. 3 is greater than 3. That's not true. Okay, 3 is equal to 3, but it's not greater than. So if the first one doesn't work, well, then you know the second one is not. It doesn't matter if the second one works or not. You have to just go with that. So it just depends on what it looks like. So remember, with inequalities, solutions are in the shaded area. If you're given a graph, just look. If you're given the inequalities, plug in for x, plug in for y. So let me see if this one works. Let's try 0, 5 into this one, okay? If I plug in 0, 5, I'm going to get 0 is greater than 2 times negative 5 plus 1. 0 is greater than negative 10 plus 1. 0 is greater than negative 9. Yes, it is. That's true. So the first one works. Okay, this one works for that. Now let's try it in the second one. 0 is less than negative 5 times 3 minus 2. I get 0 is less than negative 15 minus 2. 0 is less than negative 17. No, it's not. That guy doesn't work, so that's not true. So it just depends on which way it's given to you. But remember, solutions for inequalities are in the shaded area. All right. Moving on. Systems for equations. Systems of equations. Your choices are one solution, no solution, infinitely many. And what this looks like mathematically, sorry about that, is it looks like this. One solution would be if here's your graph and you have a line that comes here, a line that comes here, and it crosses at one point. That's your solution. There's an x and a y. A no solution in a system, there's your graph, means that you have parallel lines. Parallel lines, okay? And parallel lines mean you have the same slope. They never intersect. There is no solution. And infinitely many solutions is if you have a graph and you have a line right here and you have your second line that's literally right on top of it. So every single point's the same. Those are infinitely many solutions. So how do we do that? You have a couple ways to look at this and figure out if it's one solution, no solution, or infinitely many solutions, okay? And we want to solve the systems. So in this case, you have a couple of options. You can eliminate, you can substitute. For this one, I would just substitute because y equals both. So for a question like this, I would have 2x plus 1 equals 2x plus 6. Now, I can already see right away where this is going to go because I'm in y equals mx plus b form and I have the same slope and different y-intercepts. I know these are going to be parallel lines, but if you don't know that, let me show you how we know that. Because when I subtract 2x to both sides, they're going away and I get 1 equals 6. Everybody knows that 1 does not equal 6. So this is no solution. Because what it means is there is no number that I can put in here for x that makes this true. There's no way I can put in 1, 2, 3, 0, 20, 5 million, 200 billion. It doesn't matter. 1 will never equal 6. Okay, so this guy right here is no solution. And you can see that because they have the same slope. And when the variables drop out, they're not equal. Okay, let's try the second one. I have x minus 3y equals 2, x plus 3y equals 0. So when it's set up like this, I have 1 negative, 1 positive. I would eliminate. I would get rid of that. And then I would have 2x equals 2. Divide both sides by 2. X equals 1. I don't need to do anything else. As soon as I get a value for x, I know I can plug it back in and get a value for y. I'm going to get an x, y answer. That's a one solution. I know I get one solution. This is going to cross at one point, okay? It's going to cross wherever it is. That's what that one's going to look like, okay? Let's try this next one. Okay. I've got 5x minus 3y equals 2. 10x minus 6y equals 6. So let me write this out here so you guys can see it. Some of you guys are going to see it quicker than others. All right. So to do this problem, I'm going to try and eliminate. And to eliminate, I'm going to multiply the top by negative 2. When I do that, I get negative 10x plus 6y equals Where am I? Equals -4. Okay? So when I'm here, what's going to happen? All of my variables go away. Okay, I'm not going to be able to do anything with that. Okay, everything goes away, and 6 doesn't equal -4. Okay, so again, you have no solution. All right, let's try the last one. Okay, the last one is 4x plus 3y equals 1. 8x plus 6y equals 2. Sorry, that's a no solution. Okay, I'm going to try and eliminate. I'm going to multiply the top by -2. When I do that, I get -8x minus 6y equals -2. I just distributed that to everything. Okay? And when I have that, everything drops out to 0 equals 0. Well, 0 does equal 0. So a problem like this is going to give me infinitely many solutions. Okay, this problem is going to be right here, infinitely many solutions. It's the same line twice. Okay, do you guys see how this line is just multiplied by 2? Okay, it's the same line twice right here. So this is infinitely many solutions because whatever number I put in for x and y, if I put in the same number for both, it's always going to equal the same. It's always going to get me the same thing at the end. So infinitely many. All right, we're taking it way back right now with slope. All right, with slope, you're going to have this on your exam tomorrow where you're given a line, and then you're going to need to answer all these questions about the line. So given the line, write the equation in slope-intercept form. And if you remember, slope-intercept form is y equals mx plus b. Okay. Well, we need to get the b. The b is the y-intercept, which is right here at +2. So I get y is equal to something x, sorry, plus 2. And now I need to find the slope. So to find the slope, all we have to do is count on a graph. So I'm going down 2, 1, 2. I went down 2, and I went left 1, 2, 3, 4, 5. Okay? Or you can look at it this way. I went up 2 and to the right 5. Either way, it's a positive slope. Remember, things that come up this way are positive slopes. So this is meant to help you out too. Like, am I going to get a negative slope? No, this is a positive slope, and it's 2 over 5. Up 2 over 5. Or you had down 2, left 5, which still would have given you positive. You have negative, negative. So here's the equation of the line. Okay, given that, true, false. This is really important because this is what your test is going to look like. Is my slope -2/5? That'd be nice if you could actually read my slope, which is y equals 2/5 x plus 2. No, my slope is not -2/5. That's false. Okay, something to be very aware of on your test. If these are true, false, and you have to check both, make sure you have like a check for true and an X for false. Make sure you do both because I know it's sometimes tricky on your test. Is the x-intercept at -5, 0? Well, I don't know. Why don't we just look at the graph? Okay, here's your graph. There's your x-intercept. There's the x-axis. Remember, here's x, here's y, and that's at -5, 0. Yeah, that's cool. That works. All right. Is your y-intercept at 0, -2? 0, -2 is right here. My y-intercept is not there. Again, be careful with how these are written. All right. On the test, let me tell you, I've seen at the last 3 exams, this would say your y-intercept's at 2, 0. People are like, oh yeah, my y-intercept's at 2. Well, not when it's written like this, it's not. That says your x-intercept is 2. So careful on your exam about being tripped up by the order. It matters. Okay, f of 0 equals 2. What that says in English is when x is equal to 0, then y is equal to 2. Well, how the heck am I supposed to know that? The easiest thing to do is just look at the graph if you can. Okay, when x equals 0, y equals 2. Let me look at my graph. Here's when x equals 0, y equals 2. Yes, it does. It's on the graph. So that guy's true. And then 5, 4 is on the line. Okay. 5 4s on the line means that you're going to need to plug that in to your original equation up here. Okay, so my original equation was y equals 2/5 x plus 2. And I want to know if 5 4s on the line. There's my x and there's my y. So 4 is equal to 2/5 times 5 plus 2. Let's work with this fraction. Okay, let's deal with this fraction. Got it right here. I've got 2/5 times 5 over 1 gives me 10 over 5, which equals 2. Okay, so I've got 4 equals 2 plus 2. 4 equals 4. Yes, it does. So this guy is on the line. All right. Okay, last page. Tomorrow on your exam, you're going to have to figure out the exponential again. So the exponential, this means to find the same base. Find the same bases, and then you set your exponents equal to 0. Now, in this case right here, I pulled this from one of your quizzes because this was an ordering one of how you guys needed to figure out what it would look like, okay, if you ordered them together. And so I'm going to do this one for you guys. I'm going to write it bigger. I have 9 equals 9 minus x equals 27 x minus 4. Okay, I need to rewrite these so they have the same base. And I know that my factors of 9 are 3 and 3. My factors of 27 are 3 and 9, and then 3 and 3. So I know my common base is going to be 3. So this guy is 3 squared times 9 minus x. This guy right here is 3 cubed times x minus 4. Okay, so looking at this, to go from here to here, this is the first thing that they did. They squared it and they got that. So that's the first thing they did. Okay. The second thing they did is once these are here, you can distribute those. So I have 3 to the 18 minus 2x equals 3 to the 3x minus 12. Okay, and that is right there. That's what I did next. Once you have the same base, you have everything distributed, you can just set the exponents equal to each other. So I get, let me move this, I'll do it here. 18 minus 2x equals 3x minus 12. There's my third step right there. Okay, and then I can just solve as I want to. All right, and in this case, they did this first. So they added 2x to both sides. And they got 18 is equal to 5x minus 12. So there's the fourth thing they did. And then they added 12 to both sides, and they got 5x is equal to 30. There's the fifth thing they did, and then they divided it out, and they got x equals 6. Okay, there's the sixth step. So those steps just need to be dragged and dropped in order. On your quiz, you would see these things as a drag and drop, and then you're good to go. Okay? All right, the last thing that's going to be on your test, and it was on your homework today, so I think a lot of you guys saw it. It was on the review homework, and that is having to do with the exponent rules. So for your exponent rules, you're going to have to match them up some way, either a problem to one of these or these to a problem, and that's how you guys are going to go about these. So when you have this, okay, when you have these exponent rules, this is kind of like your base, and then how you deal with moving the exponents around on your own. And so this one right here, b to the m times n, okay? This is like a power of a power. So you would get something like this when you go, when you have like 3ab squared to the third power. Power of a power. How do you do that? Well, you multiply each one of these. Okay. When you have the little division one, okay, when you have the little division one, this one I think is the hardest. But you have a lot of different options for this. And let's say you're not good at all of them. Well, you know what? Maybe you could just kind of fake it till you make it and do process of elimination. Maybe you can kind of see what you would need. So that one, you know, I think that this one's the hardest one, but it's up to you on kind of how you guys see this. And so this would be like b to the m over n power. And an example of this could be maybe like if you had a radical and you needed to take one of them out, like how are you dealing with your exponents? What are you doing with your exponents? Okay, so you could have like 60x cubed y to the 20th. Okay, this one right here, b to the m minus n. Okay, b to the m minus n. So this guy looks like what it would look like if you had 15x squared all over like 20x to the 4th. You're kind of subtracting your exponents. Okay, and this guy right here would be like 2x squared times 10x to the 5th. Okay, multiply your coefficients, add your exponents. So this m and the n right here is really what are you doing with your exponents? Well, when I have my bases, I'm going to add my exponents. So when it's like this, I'm going to get 20x to the 10th. Okay, so those are those. Like I said, for tomorrow's exam, you are going to get a ton of factoring. Okay, you're going to get a problem like you did on last week's test where they just put up the big X with all the different boxes like this. Okay, and drag and drop them in. That question's coming back. So practice your factoring. Know when to do factoring or solving based on whether or not it has an equal sign. And then a lot of it is just review. And I think you guys are really solid with your review. Your tests before this were pretty strong. I know factoring is really difficult, but I think you guys are going to do great. So if you have any questions, you can put them in the chat. If you don't, then that's all I have for you tonight. If there's anything you'd like me to do, like I said, put it in the chat. I can make up more problems. If you have trouble with difference of squares or greatest common factor, then just let me know what you guys need. Otherwise, have a great night and good luck tomorrow. Your exam will be open from 9 a.m. to 9 p.m. Okay? All right, and I will make sure that I let your teachers know who came so that they know that you guys came and got your extra credit. So I think that'll be cool. Thanks, guys, for coming in.